Without directly diving into chapter 1, I just want to give a quick overview about what we discussed in the last class. So we went through the course introduction, so what this whole course is going to cover about, also about the prerequisites for this particular course, and also this why AI system design, so how different it is from the traditional system design which we see in our day-to-day life, as well as an interview framework. So how we're going to approach any interviews, basically system design or AI system design, any kind of interviews which require you to design a system and have a quick breakthrough of a whole software problem. So how we're going to approach that, a traditional framework. So yeah, that's about foundation 1. So we are going to start with the chapter 1, introduction to AI systems, and in this particular video we are just going to cover both chapter 1 and chapter 2. So here we are with chapter 1, so introduction to AI systems. Well, let's see some example like email spam detection. So is it an AI system or not? For example, if the developer writes like, if the email contains win money, then it's spam, and if the email contains free cash, then it's spam, and if it doesn't contain any of them, it's not spam. So in this case, the developer forces the system to go through some hard-coded constraints and then categorizes the particular email as it's spam or not. So these are the kind of systems which are explicitly programmed, and unlike AI system, let's see an example for AI system. So in any AI system, AI based email spam detection, if you have seen, you feed a lot of emails and you tag them as they are spam or not, and then the model learns the pattern. Model goes through the pattern existing in the data you have fed, and then it starts to learn that which of them are spam and which of them are not. And that's how when you feed a new mail, it actually makes the decision itself. Unlike going through the hardcore rules, it goes through the pattern it has learned so far and uses those patterns to make a prediction. So this is what basically we call as an AI system. So yeah, that's it about what exactly is an AI system versus non-AI system. Well, there is one more big difference which we see in an any AI system versus non-AI system, and it's also kind of the base to this whole course, which is deterministic versus heuristic architecture. So this is basically the important nature between any AI system versus non-AI system, where we start to see the different patterns, we start to see the variety of outputs and variety of differences which we are supposed to take care of while designing anything. So coming to deterministic systems, they were quite straightforward, to be honest. They are the systems which produce the same output for same input each time. For example, y is equal to 2x, what we have. For input is equal to 5, you always get 10. No matter you do it 10 times, no matter you do it 100 times, 2 times 5 is always 10. Whereas when you come to heuristic part, heuristic systems don't always produce definite output for a definite input. It is because they are probabilistic models and they use approximations, learned patterns, and rules of thumb to reach an answer. Heuristic systems are basically a system which actually looks for the good answer and a quick answer rather than a perfect answer. For example, I'll just give you an example on how you can relate. If you just give a single prompt to ChatGPT, no matter how many times you give, not bound to get same answer each time. So this is the actual difference. This is the difference between any AI system versus non-AI system. So a traditional system and non-AI system are bound to get same responses, and thus it doesn't become so versatile in terms of programming. But when you come to the AI system, which are bound to give different answers and have a quite wide variety of answers, it's more required that you also handle this varieties in your programming. So we'll go through the characteristics, maybe we can understand better that way. So for any deterministic systems, the rules are fixed, so they work on basis of fixed rules. For example, y is equal to 2x. the rule is that to get output you multiply x by 2. So the outputs are always exact as well, so you are always supposed to get the exact outputs. Whereas in terms of heuristic systems, it mostly goes on basis of rules of thumb, which is not strict mathematical rules. For example, if a customer buys some product A frequently, then AI systems actually recommend similar products, and these products doesn't have to be same for different users, irrespective of both of them buying the same product frequently. So that's the case with this thumb rules, that they are not strict mathematical rules. Instead, they are the rules for a system which actually tries to look for a good answer and a quick answer. So this may work often but not always, because that's the case with the good answers and not the perfect answers, and that's why they're mostly with approximate outputs. They are not the actual exact perfect output, but they are approximate output. So the guarantee of the correctness of output is not so sure, but more often than not they are better. And deterministic, they are fully predictable and the correctness is guaranteed. So in deterministic systems, the whole rules are already defined, so the output of some certain input is already predictable and it's already determined. So the output, if done correctly by two different individuals, doesn't have to be different. Whereas in case of AI systems, heuristic systems to be more specific, they are context dependent and they are fast but not always optimal. So context dependent in the sense the same input may lead to different outputs depending on the context. And also the heuristic trades the perfect accuracy with speed and practicality. So that's the whole difference between deterministic and heuristic, and that's the case with AI systems. AI systems being so heuristic systems, it gives us the advantage of being so fast and advantage of giving us good outputs, but it also comes up with so different disadvantages, that the outputs are not always fixed and outputs are not so fully predictable, so that a developer have to design the system in such a way that almost all the kind of variety of wide responses which AI is supposed to give are to be handled carefully. So that's what we are going to see in the whole course, on how wide variety of responses we are going to get and how are we going to handle those cases, and how are we going to build an effective system involving AI. AI system lifecycle. So this is basically steps of life cycle which may be involved in building almost any AI system from the scratch. Not so necessary that the system we are going to build might include all the systems, but it will include most of this, and it's not so necessary that we include all, so many of them might be skipped as well, because not skipped in the sense, let's say it's already done, so we have a wrapper of so many things already done or computed previously, so we just take leverage of their robustness as well. So coming with this first step, basically business problem. So any system, for the reason not AI system or not, it's always designed in such a way to solve any particular business problem. For example, why database was introduced, it was to store financial records. Similarly, these are the kind of business problems why we design the system. So a thorough understanding of business problem is must. So this will be base case for any system. Then the second step, what we try to do is basically data collection. We try to collect data as much as possible to analyze, assess and also to solve the whole problem. So basically we're going to collect the data from wide range of sources possible. Then we process the data. So basically any collected raw data has to be structured and brought in a common form, so that it's understandable as well as normalized for anyone to understand or make some sense out of it. The next step is basically model training. Well, what exactly is a model, first of all? Well, model is a system which actually learns the pattern from the data you feed, as well as makes the prediction according to the pattern it has learned so far. So in a simple term, that's the simplest way maybe you can put a model as. So basically, whatever the data we are going to pre-process, we are going to feed it to model so that it can also make some sense out of it and learn some pattern. Then whatever the model we get, we basically try to evaluate those models, how well the model has learned the pattern, has it overlearned or has it underlearned or something. After the evaluation part, we go through the cycle basically. If the evaluation part fails, like if the evaluation doesn't meet our criteria, maybe we go back and change the architecture or fine tune the parameters. There are so many things. So yeah, once the final model is finalized and evaluated properly, we go to the deployment phase, where we make the model accessible to the respective stakeholders, and then we make the model to be able to get the inference out of it. So inference, let's say predictions, so making predictions out of the model, whatever the pattern model has learned so far, they are made in such for a reason that anyone can make predictions out of it. For example, the email spam detection system, the model you train is done for the reason that any upcoming further mail in future can be tagged as spam or not. So basically that's the inference. So this is also a life cycle part in the production system. And once the inference is done, we tend to monitor the results. So basically this can be done through many ways, like taking the feedback from the user or so many different ways. So monitoring the results, so we monitor the load the system is getting, we monitor the results or the outputs the system is getting. So we monitor all of them and we start to improve them, continuous improvement. So basically, if we feel the model requires a big change, we go back and train the model. If we feel the model requires some slight change, or the data given to the model to learn the pattern can be improved, can be restocked, then maybe we go to the retraining phase as well. So basically this is the whole life cycle, and these are the definitions for it. It's not so necessary you understand every of them, but I just hope you just know what exactly these are going to cover up. So this is a whole life cycle for any AI system, for the result. But any systems which are more on LLM focused, the generative AI kind of phase, they tend to skip these two parts where you don't have to train, you don't have to process the data. Data collection is also optional for that reason, because that's also done. But data collection can be included if you are going to consider having your own data as well. So but data processing and model training are quite eliminatable. But yeah, so evaluation as well and deployment as well, and to directly jump into the inference part if you are going to use some generative model. So basically this is the whole AI system life cycle. As I said, yeah, some of these are skippable and some of these are not necessary that have to be included in the system you are going to build, because they are already done. So we are going to take leverage of those already done hard work and just go on to make our life easier. So that's it about system life cycle. We'll go to the modern AI architecture. So AI architectures, modern AI architectures for that reason. So we are going to focus more on LLM based architectures rather than traditional ones. That's what the whole coverage of this course is going to be. So we are going to focus more on the generative AI kind of architectures. So there are multiple architectures. These are the 4 important in the market. They are famous as well. Starting with model as a service architecture. So this is basically simplest one and the easiest one to build. So this is going to be an application where we are going to have a user who interacts with an application, and application business logic is going to interact with LLM in just one API call and then gets the responses and gets the things done. So this is basically simplest architecture as possible, and it's also fastest way to add AI capabilities to your application without having much of training and hosting headaches. So this is our first architecture. The second one is retrieval augmented generation, the RAG, which we call as. It's also quite interesting. So basically RAG architecture is something where you will have your whole knowledge base set up priorly, and user will basically ask a question, then you will have a retriever which basically fetch the important things out of your knowledge base which are concerned to this particular question, and just filter out the relevant context out of the whole knowledge you have extracted, give it to LLM, and then LLM returns your answer. So one or two more extra steps which you are going to do in terms of getting your response. So this comes up with an advantage that your model will be aware of your data, your organization's private or latest information kind of data. So yeah, this is the second architecture. And the third one is basically agent architecture. Well, what exactly are agents? I'll give you it in a good analogy. So basically agents are something which have all the knowledge of any kind of LLM. Alongside, it also has decision making abilities through the knowledge it has gained through the training. So basically agents will be given up with some such tools which can be inbuilt or maybe the custom made tools. So agent will have multiple tools, so it also has a decision making abilities to make use of tools or make use of its plain knowledge to get some things done. So basically we're going to discuss more on the agent in upcoming lectures, but this is a kind of overview. So agent will have a decision making capability to rather delegate the task to a tool or perform the task by its plain knowledge itself, which almost all the LLMs has. So user will have a goal to achieve, and agent will make use of tools or its own plain knowledge as explained, and then reaches to its final answer. So why are agents so famous? Because most of the tasks which we encounter day to day takes multiple steps rather than a single prompt. So we need to have multiple points to be taken care of, and an AI agent does exactly that. It takes multiple responsibility to take care of multiple tools, and also it take care of the exact flow of the data to achieve a certain goal which user is expecting to. So this is basically single agent architecture which we are going to talk about. And one more architecture which we are going to see is basically multi-agent architecture. So multi-agent architecture is architectures with having multiple agents. Agent, as I told, internally will have multiple tools which are supposed to execute its business logic in its own. So multiple agents of such kind under one architecture. For example, we are going to have sub agents called research agent, writing agent, and review agent. We are going to have three different kinds of agents, and on top of that we are going to have one more agent whose main task is just to delegate the task to these agents, and it's basically like the particular agent, the main agent, the coordinator one, will orchestrate the task among the existing three agents which it has. So basically these are called sub agents, and one is called the main agent. So basically large tasks can be divided into specific agents to perform some specialized tasks. So this is up with the multi-agent architecture. One more architecture I'd just like to mention is called as deep agents. Well, they are quite relatively new in terms of this agentic period. So deep agents are basically agent harness. So what exactly is harness? They are opinionated batteries with included frameworks and built-in tools. I mean to say, these are not just plain agents. Instead, they are come up with multiple built-in tools, multiple capabilities as well. Alongside that, they also have the capability to improve themselves. So how are they going to improve? There will be a main agent which is going to orchestrate the sub agent. So unlike the multiple agents what we have here, we are going to have one agent on top of this. We are considering one agent including deep agents. So a deep agent with one agent system is basically an agent being monitored by one more agent, which will whose whole work is to improve the prompts as well as the tasks and tools delegations of this particular agent. So basically the whole architecture is designed in such a way that it constantly improves the prompts as well as tool delegation of this particular agent. So it's kind of relatively new. We'll also discuss them when we are going to discuss in terms of agent. But yeah, so mainly these are the four different architectures which we are going to see more about, and they are quite important as well. So basically these are the four kind of architectures which are more used in most of the systems. So yeah, that's it about modern AI architectures. We'll go to basic terminology. Basic terminologies. So these are set of terminologies we encounter in day-to-day, also in the course. So just that I don't have to explain it each time. We are going to see all of them here. There are so many different ones, but these are the ones which will be basically used mostly. So it's better to be aware of all of this. AI. So what exactly is AI? This has we have discussed it a lot of times, I guess, by now. So artificial intelligence systems that performs tasks requiring human-like intelligence. So basically that's what AI is. Machine learning. Machine learning is basically a subset domain of whole AI, where model learns the pattern from the data. So when I say subset of AI, there are also multiple subsets of AI which can be called as like reinforcement learning and so on. There are multiple branch, of which machine learning is just one particular subset of the whole set. Model. So we already discussed, I guess. So model is a trained system that makes prediction or generate outputs. I'd like to add to this definition. So it makes predictions on basis of the pattern it learned so far from the data it's been trained on. So basically that's what a whole model is. Dataset is a collection of data used for training and evaluation. So the model what you are going to have will be trained on the data. So that whole collection of data is called dataset. Training. So training is process of teaching a model about the pattern. So the whole process of teaching a model with this particular dataset is called training. Inference is basically making the predictions. The model whatever has been trained is required to test or is required to be put to use. So that usage is basically what we make it give us some predictions. That action of getting the predictions out of model is called inference. Prompt. So prompt is basically an input or instruction given to any model. Prompt can be of multiple types: human prompt, system prompt, AI prompt, which will come into next. But yeah, so any instruction given to the model is called as prompt. Token is basically quite tricky. It's not exactly one word, which most of us might think, or not exactly letter as well, but it's a basic unit of text processed by a language model. How can we relate to this? So it's basically, there are multiple ways to get into token. So it basically strips off all the suffix, it strips off all the prefix. Let's say for calculation amount, for example, we say 100 tokens. So what exactly is 100 tokens? So there has been one particular research, especially in terms of ChatGPT. It said that out of, if you have an 100 words prompt, then it basically consumes somewhere around 75 tokens. So 3/4 of the word we can say, not exact measurement or not exact way, but yeah, that's a way to approximate. So 3/4 of the whole amount of words what you have is the token you are using. Context window, the maximum amount of information a model can consider at once. So this is a kind of important deciding factor when you come to which model to be used. Context window plays an important role. So it's basically the amount of information any model can consider at once. So some model might take very less context at a time, some can take large depending upon the model we are using. So that whole maximum amount what we have is called as context window. LLM, large language model, that's exactly what it is. These are the models with very high number of parameters, with very big in size in terms of the storage. They are trained in such a way to understand and generate text. So they are basically generative models are done to generate some text or image or audio. So these are basically the generative models, of which large language models are supposed to understand and generate something. So basically that's what an LLM is. Embedding is quite important, especially when we deal with RAG and stuff. So embedding is a numerical representation of any form of data which we have. It can be image, it can be audio, it can be video, or any plain text as well. It can be expressed as vectors or tensors. So a whole numerical representation for the any kind of data what we have, and also to not lose the meaning of the data which we are going to store. So it's not that you randomly assign some number and say that this is the embedding for so and so. So this is basically a meaningful representation and a numerical representation for any kind of data. So how are we going to get the embeddings out of any unstructured data? So there are multiple models which are meant to get the embedding out of the any kind of data which we have. For example, text embeddings, we have multiple models. For example, OpenAI gives so many different models, text embedding 3 small or something like that. For image we have Vision Transformer, ResNet or something like that. And for audio we have Wave2Vec model. So basically these all models are trained for just this whole purpose, to get meaningful embedding out of the whole unstructured data what we have. And the difference between different multiple models which I told just now is that the how well the meaning is interpreted out of the data. For example, an embedding generated by any ChatGPT's embedding model can be different from a local LLM embedding model. So the embedding representation can be different, but they all will be represented in numerical way. But how the meaning is encoded within the numbers, so that's the actual interesting part. So that's what differs. The quality of meaning interpretation is what differs from one embedding model to another. Coming to vector database, so whatever embeddings we generate, so they are basically vectors, and these vectors are stored in such a way that whenever you want to use it, for example in RAG or any retrieval systems, we try to get the vectors to get back the required information. So the meaning whatever is represented here, we try to make information out of it, we try to take information out of it, we try to take the meaning out of it. So that's why we use the vector database. And retrieval, so the process of fetching relevant information from the data source. So basically a vector database is kind of a data source. So the process of getting the relevant information out of the whole data source is called as retrieval. And RAG is basically an architecture which we just discussed right now, which combines the retrieval along with AI generated response. So basically the retrieval process is morely concerned with getting the required information out of the vector database, and the architecture, RAG architecture, is also concerned alongside the retrieval with shaping the responses using LLMs or AIs. Next part is hallucination. Hallucination is When an AI generates information that might sound so correct and confident, but it's actually false or made up or maybe like unsupported by facts. So that's what hallucination is. So for example, like if you ask a student on who invented the telephone, if the student writes Thomas Edison, it sounds believable, but it's actually wrong. So something like this. So the LLM actually give us an answer or response which sounds so confident, but it's not. So there are different reasons for why LLM might give so responses, which we'll go through later. So yeah, that's hallucination. Next up is agent. So we discussed quite a lot of times here. So agent is an AI system which is capable of reasoning, planning, and also take any action. So basically we had a brief discussion there, so maybe it might be clear out of that. So yeah, tool calling is a functionality of an AI model, or to be more specific, functionality of an agent to invoke external tools or APIs which contain business logics. So that's a tool calling. Latency is the time taken by system to produce a response. So basically the time from the request being sent to the response being generated, that's what we call as latency. And evaluation is the process of measuring the quality and performance of an AI system based on how well the responses are being generated. And monitoring is the continuous tracking of systems performance in the production. So these are the basic terminologies. There can be more, we'll discuss as it comes through, but yeah, these are the important ones which we'll be using so often, so it's better we know more of them. So yeah, that's it about the first chapter. So we are going to go through for the next chapter, which is anatomy of an AI system. So yeah, welcome back. So we're gonna start with chapter 2, anatomy of an AI system. So it's time to quite speed up the things. So we have done with all the foundation and basic requirements for this course. So we're gonna dive into somewhat a intermediate kind of mode of the particular course. So this is anatomy of an AI system. So what we're going to discuss in this particular chapter is basically a basic skeleton of any AI system, like what an AI system actually contains of, what an AI system consists of. And we're also gonna go through a code example as well, so you can visualize what the things are being done, what I'm going to explain, and how it looks in day-to-day life. So this is basically the overview of what we're going to do. We're going to discuss the skeleton which we have, and we are going to also see a code example so we can understand it properly. And yeah, maybe we'll also have a full end-to-end chatbot discussed in this particular chapter, so that you have a basic idea of what things does, and we'll just compare all the system and anatomy. We'll just discuss the anatomy of all the systems we have discussed so far. So that's it. We'll start with the anatomy. So basically any AI system, for the reason it's going to consist of these 5 particular layers. So basically the layer starts with context layer, reasoning layer, execution layer, verification layer, and a response layer. So when I say these 5 layers, it doesn't necessarily have to be all these 5 layers in one combo. Maybe you can even have verification and response layer merged together, but the core functionality remains same. And it can also be a part of some subsystem of your whole system. I mean to say, these 5 are necessarily not have to be existing as a whole independently. This can be a part of your whole system, which is basically consisting of multiple subsystems. I mean to say, any independent AI system, any independent block, for example, how an atom looks like. So this is basically what you can call as an atom in terms of AI system. So it's the independent blocks which together constitute AI systems, which can be independent or multiple. So it depends, but any AI system will be basically comprising of these 5 particular layers. Starting with context layer. So context layer is the actual knowledge part of the particular whole system. So the main functionalities of this particular layer being retrieving the data, which can come from various sources, maybe vector database or any files you upload or files you ingest. It can come from various sources, even your previous conversation history or some your personal details through your user info or so many things. So context layer is basically a kind of knowledge source for the particular whole AI system. It acts as backbone of knowledge. So once you retrieve all the data required, you go to the reasoning layer. Now reasoning layer is quite interesting. So this is basically the kind of layer which decides how the whole AI flow goes like. So for example, it can do tasks like intent detection, planning, decision making, and tool selection. So intent detection is basically like whatever query comes. Query can be dynamic. For example, if we just consider a customer support bot which are going to design later, yeah. So there can be multiple kind of queries. For example, one can be of order cancellation request, other can be of something like order return request. So there can be multiple intents behind a query. So for an AI system to decide what exactly is this query inferring to, maybe that particular thing we can call it as intent detection. Then yeah, planning. So breaking down of big tasks into small individual tasks so you can do it independently. Maybe that's that you can put it as planning. And decision making and tool selection. So basically when you ask AI to perform an addition, then AI has to take a decision whether it has to use additional tool or subtraction tool or so on. So tool selection is basically one more component of reasoning layer. So this is the second layer. This is basically kind of the decisive making layer, maybe we can call it as. And third layer is execution layer. So all the business logics whichever we are going to write will be like enclosed within this particular layer. For example, database access, API calls, tool invocation, updating the states. So all this execution related tasks, all the business logics, all the services are maybe mostly going to be covered within this layer. The reason for this layer relevancy as well as importance is that this is the main task which AI is going to execute. So basically although this layer is quite important for knowledge and this layer is to make the decision, when a decision is being taken, it's also important how well you execute it. Like the planning is fine, but the execution is what is more important. So basically this layer focuses more on those execution tasks. For example, if a particular consumer wants to cancel an order, there are multiple things involved. Firstly, you have to write into database that first you have to verify maybe that does the order exist or not, or the status you have to fetch, so that if the order is already cancelled or not, if the order status is already delivered or shipped or not. So basically there are multiple checks that can be done, and then maybe you can set the status as this particular order can be cancelled. Then you cancel the order, you write it into a database, then you go to the consumer or the consumer and just mention that we have started your cancelling process, and then you go to the shop and just inform that this order can be cancelled. So there are multiple steps that has to be taken, and what are the steps that we are going to be decided in the reasoning layer, and how the steps are going to be taken, that we are going to define in the execution layer and also use them in the execution layer. So basically this is kind of the backbone of the whole thing. This can be considered as brain, and this can be considered as probably the decision making layer as nervous system or something, and this is the sense organs, the organs which actually work. And final layer is verification layer. Verification layer is quite modern, maybe we can say it as something of an extra layer which can shape your responses better, something more of like a enhancement part. So what this layer is basically responsible for is simple. It actually checks the custom logic. For example, if you're having a bank related customer chatbot, then it's better you don't leak sensitive information, for example some bank's user ID or something like that. So verification layer does this task, like it filters out the request or the response which are sensitive, which are quite as per the business requirement. For example, if some chatbot, let's say, doesn't want to give any global YouTube link, for example, for an any chatbot which doesn't actually intake or give YouTube link, and now if in prompt I just ask the chatbot to go through this YouTube link and I paste it, it actually, the verification layer is what it goes through first, and it just checks on if the given response by the AI has some YouTube link or not. So this is my business requirement. So verification layer mostly revolves around the business requirement. For example, if a customer doesn't want his bot to have some images or something like that. For example, also recently we had Grok being asked to generate some weird images. With verification layer, you can improve the kind of images generated. Once the image is generated, maybe you can even have a grader which can say how bad is it, how does it align with the policy of this particular product. So this kind of checks can be done in verification layer. So among this, policy checks is basically the one I mentioned, the custom policies, whatever they may have. Validation is, of course, whatever the execution results are coming, are they fine, are they aligning with what our requirements are. Guardrails may be something we can discuss a bit. So basically, this is important. It is basically kind of something like accessibility kind of thing. So for example, if the request or user's query goes of something like how to crack my neighbor's Wi-Fi password or something like that, you see the intention being not quite unethical, and if it doesn't align with what my AI system is going to do, maybe we can block the request right there and just give output as this request doesn't align with our policies, something like that. Or even if your AI response is going to be something like, after the execution layer, the response is something going to be like your customer ID is so and so and your password is so and so, something like that, maybe out of many reasons. If that's what the response came, then verification layer is quite decisive in that case, where it holds on to the responses which go beyond what it has to be. So those are how guardrails are being used. So it blocks the request or the responses which doesn't align with the policies or the predefined rules which we are going to have. And the final layer is a response layer. Response layer is quite basically a layer which shapes our input. For example, if AI just gives answer as 4 for 2 plus 2, then maybe a response layer is instead of just giving plain 4, it gives like the result for adding 2 plus 2 is 4, something like that. So basically shaping of your output, shaping of your naive output into something which can be very descriptive and better for user to understand. So this is basically a tool or a layer which is focusing more on how well the user interaction performance is. So basically this is what this response layer is going to be. These are basically 5 layers which will be comprising a complete AI system. As I told you, it doesn't necessarily need to have all 5 layers. For example, if you can even have somewhere some reasoning layer eliminated in sometimes, and sometimes maybe you don't have verification layer, sometimes you don't need context layer. For example, if I just ask 2 plus 2, I don't need to retrieve user's whole data for that. So there are multiple ways, multiple dynamics including, but it's up to us on our common sense on which layer to be included and which layer to be not. But yeah, these are the 5 layers which makes a AI system decisive. So this is with actual layers. I want to take you through a code example. Maybe we can see how things work in real time. Maybe I can make you go through all the layers individually for a particular business problem, and maybe we can visualize it better, I guess. So yeah, so this is the, I'll be uploading the code. So yeah, this is the code. we are going to have one JSON file, which is basically going to have user data for 3 particular orders, for 3 particular customers. So we have 3 customers. One is John, Alice, and Bob, and we have status of order of Bob being cancelled and someone's being delivered and shipped. So this basically assume this is how the database is going to be stored in real time as well, but we just have to, our focus is more on how the systems are going to be responsive. So we focus more on AI part rather than how the database is scaled or how this database is designed. So this is just for a demonstration purpose. So yeah, starting with I'm going to use Gemini for this whole course. A simple API key is more than enough. And one more thing is to make use of Gemini, if you're not familiar with this, you can make API keys easily. You just need to go through Google AI Studio and make your API key, and API key might something look like this. So I have blurred this so far, but yeah, API key looks something like this. Okay, so I'll try to explain line by line. We'll see. So this is LangChain's Google generative AI support. So we're going to use that, and this is basically an a library which can help you import the variables from the .env file, whatever you're going to have. You are supposed to get your API key and set it with the same Google API key as the variable name and add your API key here. So that's it, and load.env is the function which is going to load the .env into your runtime. So that's the first basic setups whatever we are going to have. And remember, all this code I'm going to be doing in the Jupyter notebook. So we are going to look at code example basically, as we have already seen some various layers of an AI system after a whole anatomy. I just want to take you through a simple customer chatbot, which will basically be doing the order cancellation part, as well as maybe getting status of the order, something like that. We'll be having basic functionalities, but we explore all the layers so that we have a basic idea of how the code looks like. We'll catch up with the starting with some small foundation kind of things, and then we'll scale up soon. Starting with before going into this whole code, I just want to explain the setup. So basically we're going to have an JSON here, which is basically a replica of database. So instead of having a sophisticated database, we are going to use this whole JSON as our whole database, because we are more into focusing on how the layers are structured, how LLMs are utilized in this application, rather than how well our database is orchestrated or something. So yeah, for now, just for demonstration purposes, we are going to use this as our data. Also, we might have to have an LLM, so we are going to use Gemini throughout this whole course. Reason being, it's good enough for this small task which we are going to do, and also it's cheaper to in terms of cost. So how are you gonna access it? So you are basically required to create a Google account, which I assume you have by now. So you just have to go to Google AI Studio, you create an API key, and you will get some API key starting with letter A or something like this. You have to make a .env file. It's best you do it in the .env file. It's basically a file consisting of all the environment variables and the secrets. So you are supposed to set it as Google API key here, which will let the program know that your API key is stored in this particular variable, and you have to store your particular exact API key, which I'll have which I have blurred so far, but it will you will get a big string of basically the API key. API key is basically a kind of signature to let LLM let the server know that you are the one accessing. For example, my API key just tells that user from this so and so email ID is the one accessing, and that's how it works. So this is the setup. So as we discussed, we have 5 layers. So starting with, we'll go through the code itself. So basically, this is LangChain's model, LangChain's classes to access LLM models of Gemini. So Chat Google Generative AI is basically an interface which will allow you to access the models. You don't have to worry about these names. You can, it's easy, and as you go on, you will be able to catch up these things. One more is .env. So basically, this is a library which imports the environment variables, whatever we have in .env file, and load it to the environment. And talking of environment, so we are using notebooks instead of plain Python file. So I can show you execution function by function, like how the layers work one by one instead of directly seeing the whole output. So yeah, basically load.env is a function which will load all your variables into the environment. So for example, I can show you one. So we have a variable Google API key here in our .env. So on loading this particular .env, you'll get to see the actual environment variable name. So Google API key is the key variable name. Alongside that, we have the so and so particular API key. API key, the one existing, I'll be invalidating it so far, but yeah, so that no one can use it. But yeah, it's suggested you don't show your API key this way. Starting with, next we are going to basically instantiate our LLM. So whereas this is the interface which you imported here, and you are supposed to specify a model here, the model name, whatever you're going to be used. So basically Gemini 2.5 Flash is a cheaper model and a better model for all these business purposes, where you don't have so much intensive intellectual tasks and just require some basic intelligence. Maybe you can go with this model. There are also some parameters. For example, there are some parameters called as temperature. Maybe I can just explain. These are actually just attributes of the model, whichever you are going to use. So the temperature ranges from 0 to 1, and it's basically kind of how much randomness the response should involve. So basically we can set it for 0.2 or something like that. It must be a decimal ranging from 0 to 1. And there is one more thing. If ever suppose you fail to load env with this particular ID, which is Google API key, if you are failed to load with this particular variable name, you can actually give that as a parameter here. So there will be a parameter called as API key. You can change the name, and you can load the name dynamically here, whatever you are going to do. For example, instead of Google, I do Gemini. Then it's better I do Gemini here as well and load the same and then use it here. So basically this is one more way to manipulate API key and stuff here. So we'll see the first layer, basically context layer. So context layer is as we discussed, it's basically a layer which retrieves all the data, whatever conversation history, user info, or any data. So the retrieval part of that particular data will be done in context layer, basically. So in our context layer, we are just going to have finding the order details. So from this database, which is just JSON here, we are going to get the whole order details just using order ID. So that's the whole thing which is this function is going to do. So we basically get the JSON file. We just load that JSON file into this particular variable, whatever will be there in this, and we'll look up for the order ID and we'll just return the whole order detail. So how does this work? Maybe I can show you better way. Yeah. For example, if I just want to find out order details of some order ID as 12345, which is basically John's order and which is already shipped. So you do it something like this. So we get the order details, 1 2 3 4 5, customer status, estimated time, and so on. So this is how the context layer for this particular problem is designed. The customer chatbot which we are going to have, it can be done in various different ways. For example, instead of this, you can have your own database, or you can also use the session memories to use the particular user's information, user name, and so on. So we'll see these middlewares in the upcoming lectures, especially some of the middlewares are so important. We'll see in the upcoming agentic part, but yeah, so this is the context layer which we are going to use. Then comes the reasoning layer. So reasoning layer is basically straightforward. We are just going to have a reason and deciding of what we are going to do. So basically intent detection, like what this particular query is about, like what the user is trying to get done. Planning, like what tasks to be divided, and so on. Decision making and tool selection, like out of so many tools whatever we have, which one to be used. So here we are just going to replicate intent detection. So basically how we are going to detect the intent is simple. We'll take the user query, we'll just add this as a prompt, and whatever the query will be there, we'll directly inject it here. And this is an instruction for the response, like what are the intents that you are you just give me the intents and nothing else. And this is basically kind of intents which I have previously defined. So I expect LLM to take this query, find that what user is trying to do, and basically give me one of these two intents. So I can show you something. So this is a function. So what we do here is, once the prompt is done, we use the LLM which we defined here. So we use this LLM, and dot invoke, what it does is it basically enables it contacts the LLM, whatever the model, whatever we have decided, which is Gemini 2.5 in our case, and it sends the query as the prompt whatever we have, and it gives us a response. So it basically gives an AI message response, but you don't have to worry about it. It's just this is what it's important, like what the content of the response is alongside the prompt. So this is one such response. So basically LLM.invoke, so whatever the model response will be, it basically looks something like this. For example, in for this particular one, hello, I want to track the order even with the spelling mistake. So it tries to get the intent, which is tracking the order. It gives so many different things, for example so many metadatas. For example, it gives us the model which we are using, safety ratings. ID run is basically the user ID which it's used, and you get so many things. Out of this, only content is what are useful to us for just for this particular case. So we are going to use response content as well, and also the prompt. I just want to show you guys the prompt. So basically, if I can show you, this is the prompt. So this is how the prompt will be injected. For example, all these things will be same exactly here, but my user query was that hello, I want to track the order. So what it does is it replaces the exact query as it is into the prompt and then sends it to the AI. So basically this is what this curly braces does inside the prompt. So this is it about reasoning layer. So basically in our reasoning layer, we are just going to find the intent, what this user is going to do with this particular query, and give us the actual intent. So what exactly is the intent? Maybe you can see here. So it says track the order. So basically with this particular query, the user's intent is basically tracking the order. So yeah, that's it with reasoning layer. Coming to third part, execution part. Execution layer is basically kind of heart of the whole thing, like the whole intent. Once it's detected, we just have to process them. So the business logic of doing things will be basically mentioned in the execution layer. So what are we going to do here is, if the order's intent is tracking the order, then we just return them the status. So what is the exact status of the order, we're just going to return that. But if the intent is basically cancelling the order, then we have to process the cancelling. So how are we going to do that? We first check if the order is shipped or not. If the order is still in processing, then maybe we can cancel it, and if it's not, then we can't cancel it. So before going to how we are going to cancel, I just want to give a bit on this. So basically intent comes from the reasoning layer. So reasoning layer gives us two kind of intent, one is track order, one is cancel order. So if the intent is basically track order, then we just set the status as then we just give them the status, because tracking just have to mention them what is the status, so we just give them the status. And if the intent is basically to cancel the order, then you just check the current status of the order. If it's already delivered or shipped, then you obviously can't cancel. But if the order is still in processing condition, then you can cancel the order. So how are we going to cancel the order? So firstly, we load the database, we find the status, and we set the status into cancelled. So basically for the particular order ID, you set the status into cancel, and then you write it back to the database, and then you just give them that the particular order is cancelled. So basically this is how we are going to cancel. You load the database, you find the order ID, you set the status as cancelled, and then you just write it back to your database. So it's a simple process. The whole business logic is just these things, that you classify the intent. If it's tracking the order, then just get the status. If it's cancelling, then you just write it into database. So this is basically the execution layer of our particular customer chatbot. Final one is basically verification layer. Here it's simple. So what we're going to do is, if the intent was cancelling the order and the status is already shipped, so then we basically just ask it something like order is already shipped or something. So this is basically a layer on top of everything, so that we have a sophisticated verification of whatever has been done so far. I mean, if you are trying to cancel an order which is already shipped, then it definitely doesn't align well. So that's why we are just going to have it as order already shipped. And finally, generate response. Generate response is our whole prompt. So basically what we are going to take is use a final response, the response layer, which will be designing as our final whole response, the sophisticatedly well formed natural language. So for the particular user question, for the particular order detail, this is the execution result and this is the verification result. Now generate a helpful customer support. So this is the prompt which we are going to give it to LLM. So basically like I showed the user query there, we are going to replace the user query exact, orders details exact, and so on. So all these curly braces will be replacing the exact values which we are going to pass here. And then you again llm.invoke, which will basically sending the input to AI, and then you get the response. So response.content is important here, because llm.invoke directly doesn't give us the whole answer, so you just have to do dot content to get the answer. So yeah, this is about 5 layers. So maybe we can execute all of them so that we can see in real time how they look. So this is basically the function which has all the layers. So firstly is context layer, where we load the order as we discussed there. Then we find the intent with the user query. Then execution result will basically execute the intent. If it's cancelled, then it cancels the order. If it's getting the track, then it tracks the order. And verification result just verifies the response, and then finally you just have a generate response which will shape into your natural language. This is the layers. This is the 5 layers which we discussed. So yeah, we load the order data here, we find the intention of tracking or cancelling, we cancel the order if they ask, or we get the order details if they track, and you just have a simple verification layer which says if you're trying to cancel the order which is already shipped, then you just mention that this is already shipped data, and the final response is which will consider all the 4 outputs and just shape into a good natural language response. So we'll run this for demonstration purpose. let's say the order 54321 is still in processing. Yes, so that we can demonstrate cancel as well as the tracking as well. So basically we'll start with this is a main function where we just intake the order ID, and this will run basically like a simple chatbot. Maybe I can show you. Yeah, so we get to enter the order ID. I'll just give the order ID as 54321, which is basically Bob. So enter the query. So I just say track me this order. So for the order ID 54321, which is the print statement I have added here, so that we know what exactly is the order ID we are looking for. Then yeah, your order is currently processing and is expected to arrive by June 10, 2026. So what it does is it first finds the intent that I just want to track. Then after finding the intent, it just executes the intent, which is basically fetching the status. It says June 2026. It verifies the response. So let's try like canceling the order. English, so how the canceling of an order is going to be generated through the generate response. We'll try to cancel the order. That's how it works. One which is still in processing condition maybe. So starting with 54321. Yeah, so you don't necessarily have to use this kind of input box which I just used because it's better to it's simple to demonstrate. You can have your own interface. You can have this TCP connections going on and send the backend request and so on. This is just simplest way of doing the chatbot. That's all. So if you see, the status got cancelled itself. So this, considering this our database, as soon as I asked to cancel the order, the status which was earlier being processing got changed. So that's how the database works in real time. When I have a business logic which tries to manipulate the database, it does so far, and this is a proof that how our business logic is also being executed. So that's it. This is the response layer which says your order ID with so and so has been successfully cancelled. The status of your order has been updated to cancelled. Please let me know if you need any further assistance. So yeah, that's how this whole thing works. So we basically will sum up the whatever we have done so far. We built our own order details, the context layer, which will basically retrieval of whole data, which we used as a temporary database to retrieve whole data from this particular database into our runtime. Then what we did is, for a particular user query, we tried to determine the intent through our LLM. So for now we only have two intents, which is basically tracking the order and cancelling order. These are the only two services which we are providing. So we have two intents to be determined and proceeded. What we then did is go to the third layer, which is basically our execution layer. So whatever the intent, depending on the intent determined through LLM, we just pass the intent and we pass the order ID, so that order detail, so that we know what order is going to be manipulated. So we have two options here again. You can track the order or you can cancel the order, and for cancelling we just cancel only the ones with the processing status which we earlier saw. So this is basically the cancelling order, where we also update our database. So that's what we did in this particular function. And the final one is verification layer, where we basically verify the response if the order being trying to be cancelled is already shipped or what. So basically this is verification. And generate response, as we see, we saw so many sophisticated natural language as a response. So basically yeah, this is how a simple AI system looks like. So this is basically the chatbot. Any chatbot you build will basically be comprising of all these layers. You may even skip one or two, but yeah, these are the ones which are mainly used. And here we had a main function which just runs through an interactive kind of session, but you can also have a well sophisticated interface. You can have your own UI, you can have the messages recorded well. This one is just done for the demonstration purpose, so maybe we didn't focus much on the front end part, which is of course not the goal of this course. So yeah, that's it for the architecture part. I mean, how a simple practical code looks like. Maybe if we come to this is what we did so far. Like, can I cancel the order 54321? Then custom the support bot basically gives us a good message alongside doing all the business logic. So that's what an simple AI system do. It does your business logic, and it additionally also give you well sophisticated message which informs whatever it has done so far. So that's it with whole anatomy for AI system. There is one important thing, like comparison of multiple systems, whatever we have, multiple kind of architecture. Basically, we see their particular layers. So layer wise, for any simple chatbot, the context will be its chat history. For example, the ChatGPT application which you are going to use, it does, although how the history is collected is quite different topic which we will discuss later, but ChatGPT takes your chat history as your context, so it remembers your name. It doesn't ask your name always, so it remembers the context as your chat history. Whereas for RAG systems, the documents that it's going to retrieve. So basically, I guess I explained it in architectures, but yeah, RAG is basically a system which gets the relevant documents or chunks from any database or any data source, and that's what will be used as context. Whereas for agent, it does both the context as well as memory. It also has the chat history, alongside it will also take context from various sources. Whereas multi-agent, it will have a shared context, so the context will be shared between the agents. For example, for a single agent, it will be both memory plus context, and for multi-agents, it will be multiple agents sharing the same memory and context. So this is with respect to context layer among the multiple architectures what we have. Then comes the reasoning part. So reasoning for ChatGPT is basically intent understanding. Chatbot, where chatbot doesn't have to do so many things. It just have to be a well conversing agent. So all it does is intent understanding. So that's all its requirement is as well. To converse properly, it just have to be aware of what exactly user is trying to ask, and just catch it straight to the point. So that's what chatbot is basically made for. RAG, the whole reasoning part, the decision making part, is basically the planning one, like how you rank your whole retrieved documents and so on. For agent, it's task planning, like you break down the whole tasks, and for multi-agent, it's agent coordination. So among the multiple agents, have the task is distributed, so your resources are utilized properly. So something like that. Coming to execution part, for chatbot, mostly database lookup or some business logic executions, as we saw in our example. So that's it, I guess, the most what we can see in any chatbot. Other than that, for RAG, it is basically the retrieval part. So when we say I want some details regarding so and so query, then retrieval is the execution part in the RAG. For agent tool calls, the call once the task is planned accordingly, the tool calls will be corresponding according to the task planned. So for agent, the execution is tool calls, and for multi-agent systems, multiple agents actions and their executions are the execution layer for this. And for verification layer, chatbot will have some business rules. For example, we had a constraint that shipped orders can be cancelled. So something like that, some business rules will be defined from the user's requirement, or maybe a predefined policy or something. For verification, for RAG is grounding checks. For example, if I retrieve 5 to 10 chunks for a particular query, then I just have to verify how well the answers have came so far. How well is the answer actually relevant to my question? For example, if I just ask what is the capital of India and it says some 10, then the answer is not relevant. So that kind of checks is going to be the verification layer for RAG. And for agent, the guardrails, as we discussed, like how we have check before check among the non-ethical or ethical part, or so many different policies. So this is for particular agent, and for multi-agent it's cross-agent validation. Like you will have a different agent which will validate and verify your response. If it's not, then it just goes back and tries again. So something like that will be seen in multi-agent environment. And the final part, the response, the basically the most important part which can be seen by user to judge. So for chatbot it's the chat reply, like something like this what we see. For RAG it's the answer generated with the documents retrieved. So basically if I try to ask a query of considering a whole book, then we just get some one line or two liner answer or something like that. That whole generated answer will be through LLM, and that's the actual response, that's the output of the RAG. For agent it's the final result. It doesn't necessarily have to be some English output like this. It can also be some business to services executed, some database calls done, some API calls done. And for multi-agent it's aggregated response of multiple agents. So in a system consisting of multiple agents, all of their responses have to be aggregated and synchronized in such a way that they perform the task perfectly. So that's how multi-agent system works. So yeah, this is the 5 important layers in any AI systems. So these are the important kind of most famous architectures which we see in day-to-day life. And this is the architecture, this is the layers which we are going to be implementing in any simple AI system. Will be also the code. I highly encourage you to go through this whole code and maybe try yourself and do things, especially try to play around with this particular part, llm.invoke, which will basically send request to LLM and get you some output, and also play around with the AI message content part. So basically the whole response what we had, maybe you can play around with how the responses will come, how the query is going to inject, and so on. So try to play around with these things, so you you can make yourself better in this. So this is basically a simple chatbot. You can try various different things. For example, you have your own instead of having some simple database like this, you can you can connect with your actual real-time database. Instead of loading the JSON, maybe you can call the DP and get the records and update it back. So there are multiple things you can even improve with this, with a better UI or something like that. So yeah, this is there are so many things to improve, but the main aim why this example was introduced is to make you familiar with different layers. For example, we have gone through all the layers and how each of those individual layers work. So I just want you guys to see how the layers are designed, and build the systems which has all these layers in place and work in a synchronized manner. So that's it for this chapter 2. In the upcoming chapter we are going to have a discussion on basically model serving and inference systems. So this is going to be quite kind of theory-ish part. So maybe we can see some of the practicals in terms of caching and batching, but yeah, we'll basically go to chapter 3 in next particular video. Thank you.